Hello, this video is about verifying trigonometric identities. So in this example we have two identities and let's see if we can convince ourselves that they are true or not. Let's see. So how do we do it? One way to do it is to start with one side and get to the other side, but our functions are complex. They are made up of sines and cosines. So it may be easier to convert both sides into sines and cosines just to see what they look like. So let's do that. The tangent is the sine divided by cosine. The cotangent is reciprocal, is the flip of tangent. So we would get plus cosine divided by sine. On the right side, we have secant, which is 1 divided by cosine, and cosecant is 1 divided by sine. Now at this point, we see that on the right side, on the bottom we have sine times cosine, on the left side we have sine plus cosine. In order for us to combine these two fractions, they need a common denominator. And that common denominator is exactly sine times cosine. So what we need is we need to multiply the first term by the sine, so we have the common denominator, so top and bottom gets extra sine, and the second term gets cosine. Now we have sine times sine, that's sine squared, divided by sine times cosine, and here we have cosine squared over the same denominator. So we're combining them, and now we have sine squared plus cosine squared over sine times cosine. Well, we know that sine squared plus cosine squared is equal to 1. So now we have 1 divided by sine x times cosine x. And if our instructor doesn't like working with two sides, we don't need to do that. We can just do this piece on our own scratch paper and don't show it to anybody. Simply use it to motivate our own solution. And then from here, we can continue. We can split up this fraction into 2 and call it 1 divided by sine times 1 divided by cosine, and then convert 1 divided by sine into cosecant and 1 divided by sine into secant, and we would be done because we have started on the left side here and we have arrived at the right side, so we have showed that the two sides are equal to each other, and that's the end. That is how to prove that the left side equals to the right side. Now the next identity has two fractions, but they're both in terms of sine and cosine. So in this case, we need something special. We can multiply top and bottom by anything we like, but it is very useful to know that the formula for the Pythagorean identity sine squared x plus cosine squared x sometimes shows up in a different format. We can solve this formula for either sine squared or cosine squared. So for instance, we can say cosine squared is the same as 1 minus sine squared. And that is a true statement because it comes from the formula that we have already established. Now, if we look at our expression and we multiply the left side by 1 plus sine, so here we multiply 1 plus sine and 1 plus sine. Now, on the bottom we have 1. Let's multiply this out. 1 times 1 is 1. 1 times negative sine is negative sine. Sine times 1 is positive sine. And sine times sine is negative sine squared. On the top we have cosine x times 1 plus sine x. Now the sine plus and minus cancels off. and we get 1 minus sine squared. Well, 1 minus sine squared just happens to be equal to cosine squared. So we can replace the bottom with cosine squared. On the top we have cosine x, 1 plus sine x, and one cosine cancels the other cosine. So now we have 1 plus sine divided by cosine. And what do we have on the other side? Well, we have exactly the same expression. Here it is, 1 plus sine divided by cosine. That's exactly what we came up with. So this is how to prove one of the ways to show this identity. And that's it for this video. If you have any questions on anything, please let me know. Thanks for your time. Take care.